Okay, this is a screencast on electronegativity, and the idea is that you understand what electronegativity is, that you can define it, and then you can explain the trends going across a period or down a group. So, questions that kind of get us started is really what is meant by the term chemical bond? Why do atoms bond with each other to form compounds? And how do atoms bond with each other to form compounds? So why and how? Right? So types of chemical bonds, and we've talked about this. It's forces that hold groups of atoms together and make them function as a unit. Okay, a bond is going to form if the energy of the substance that is formed is lower than the energy of the separated atoms. Okay. And there's a term that we'll define again later called bond energy, and that is defined as the energy required to break a chemical bond. Alright, so we've known about ionic bonding. Ionic compounds result when a metal reacts with a nonmetal. Electrons are transferred between the two, and we get this whole ionically bonded, remember it's a whole big crystalline structure, right? 3D's going with 3D structure with anions and cations held together by electrostatic forces, the attraction between oppositely charged ions. And then we have covalent bonding, which results when the electrons are shared by two atoms. And here's the idea. I've got my hydrogen atom shown with the electron cloud. When they come together, they form a molecule. Okay, we would kind of draw it like this. And you can see that in that the electron density is more between these two nuclei because of those attractive forces. And that's a covalent bond sharing between the two. Now, when we get into bonding, which is the next unit, you don't have to know this at this point, but we're going to talk about polar covalent bonding. And that's an unequal sharing of electrons between the two atoms in a molecule. One has a greater pull or an attractive force for that electron pair in that bond than the other one, and it's an unequal sharing. And what it results in is an unequal charge distribution across the molecule. One side is going to be slightly more negative, the other side can be slightly more positive. And you've probably talked about that with the water molecule in biology. Well, and if we were to draw a polar molecule with electrons, probability, like where the electrons would be, here you would see in a bond between hydrogen and fluorine, the fluorine would be able to attract that pair of bonded electrons more to itself than the hydrogen can, and that results in a polar bond. Because the electron is held or attracted more to that fluoride ion, that fluoride half of this molecule is said to be partially negative, and that's a symbol that you can use to show that. The hydrogen is then partially positive. And again, these are polar bonds that we'll talk about when we get to bonding. But now we want to talk about how do you decide what kind of bond we'll have. And you can answer these questions, and we'll get better as the next unit. How we determine whether a bond is nonpolar, meaning equal sharing, or whether it's polar, unequal sharing of that pair of bonds, or whether it's ionic, meaning one atom has a strong enough attraction to attract those electrons to itself all the way, resulting in an ionic bond, is something called electronegativity. Electronegativity is defined as, and you should know this definition, the ability of an atom in a molecule to attract shared electrons to itself. For a molecule HX, the relative electronegativities of the hydrogen and the X atom are going to be determined by comparing the measured bond energy with the expected bond energy. And what they get for that is a number for the electronegativity. We are more interested in being able to say what the general trends are. On a periodic table, electronegativity generally increases going across a period and generally decreases going down a group. Think about the atomic radii and why this might make sense. Okay. The top number for electronegativity is 4, and that's for fluorine, the most electronegative, and 0.7 for the least electronegative. So let's talk a little bit more about why the electronegativity increases going across a period. Well, remember, atomic radii increase, right? So atomic radius increases going this way, right? No, it decreases. Atomic radii decreases going this way. Why is that? Because remember, for every place I move across, I'm adding one more proton. Okay, but I'm adding electrons to the same energy level. So my attractive force for the electrons increases due to increasing nuclear charge with electrons added to same energy level. This will correspond to the attraction that that nucleus will be able to exert on an electron or an electron pair in a bond. The smaller the radius, the more attractive force it'll have, the more it will pull that pair of electrons to itself. Similarly, increasing or decreasing electronegativity going down a group corresponds to the atomic radius increasing due to added energy levels, main energy levels, as I go down a group, okay, shielding the nuclear charge from outermost electrons. Okay. So the ability of an atom or a nucleus to attract a bonded pair of electrons is going to decrease as we go down because the atomic radius is increasing due to added main energy levels and a shielding effect between those electrons and the nucleus. Okay. So if lithium and fluorine react, what has more attraction for an electron and why? We're just going to stop with this question. Hopefully you would say fluorine. One, fluorine is the most electronegative element because it has the smallest atomic radius, the highest attractive force between the nucleus and electrons. Okay, so fluorine will have a greater attraction because it has the most positive nuclear charge and the least amount of energy level, so it is most able to attract electrons. Okay, and that ends the screencast for electronegativity.